Okay, this is Stats260. We're looking at Chapter 9. This is 9.3. I want you to amend the notes on page 2. I think it says Z right there. Cross off the Z and make it a T. That shouldn't be a Z. That should be a T. So this is a T distribution we're using when we don't have the standard deviation of the population. We only have the standard deviation of the samples. And so just like before, this, for our purposes, is just going to be 0. So let's read. The average size of a farm in Greene County, Pennsylvania is 199 acres. Average size of a farm in Indiana is 191 acres. Assume the data were obtained from 2 samples with standard deviations of 12 and 38. See, right there, that would maybe be a red flag. Like, why is there so much variation in the Pennsylvania farms? Like 3 times the amount of variation, right, with the standard deviation. Sample sizes are 10 farms and 8 farms. So these are small samples. So we definitely use T because it's such small samples. Can it be concluded at alpha equals 5% that the average sizes of the farms in the 2 counties are different? Assume the populations are normally distributed. Okay, so they have the null and they have the alternative. So again, this is a two-tailed test, just like on the first problem, because it's not equal to. Since it's not equal to, it's a two-tailed test. And this time we'll take a look at the chart. I'll show you the chart on the video. And so we want to look up T for alpha is 5%. Degrees of freedom. So now look, we have 2 different sample sizes. We have... what do we have here? N1 is 10 and N2 is 8. You always use the smaller of the 2 samples to figure out the degrees of freedom. When there's 2 samples to be had, we're going to use the smaller one for the degrees of freedom calculation. So the degrees of freedom are going to equal 8 minus 1, 7. All right. So we're going to look at 7 degrees of freedom. And we're going to find the t-score for a two-tailed test of 5%. So that's a mouthful. Let's take a look on your packets. That's table F. And so there is our t distribution. We want 2 tails. See on the top, 2 tails. And we're going to follow that over to 5%. And then we're going to follow it down to 7 degrees of freedom. So 7 degrees of freedom. And there we are. 2.365. 2.365. I hope you're looking with me. All right. So 2-tail test, 5%, 7 degrees of freedom. So that is our cutoffs. So these ones, we cannot find the probabilities like we did on the previous chapters. So T is equal to 2.365. T is equal to negative 2.365. So we just have to use our T scores. And so if it ends up to be 5, then we'll reject. If it ends up to be 1.3, then we fail to reject. All right? So let's find out what it's going to turn out to be. Compute the test. So let's do that. So they have a little space for us to do that. And they have the answer too, though. So 199 minus 191. It's minus 0, so we don't care about that. Over the square root of the first one had a standard deviation of 12. So we'll do 12 squared. We actually want the variance. Divided by the sample size, 10 for that one, plus, I told you this was alarming, 38 squared. That's pretty big compared to this. That's pretty big. And there were 8 samples in that one. All right. So you might want to put this in your calculator. The top you can just subtract, but the bottom you might want to do these independently. So look, that's 12 times 12 is 144 divided by 10. That's 14.4 plus 38 squared divided by 8. That's 180.5. And then you add those two together. So we got 8 over the square root of 194.9. And then, so here's my t-score. My t-score ends up to be 8 over 13.9607, which is 0.573. All right. And now it doesn't matter if it's positive 0.753 or negative. That depends on which one you put first or second. So I happen to put the 199 first and the 191 second. If you flip those around, it would be negative 0.573. And it doesn't matter because it's still going to miss the mark on either side. So it does not matter in these cases where you're comparing things. It doesn't really matter which mean you put first and which one you put second. All right, unless it's a one-tailed test, and then you have to be, mindful of which one comes first or second. But in a two-tailed test, it won't matter. All right, so 0.6 standard deviations, we needed it to go 2.4 or higher. And 0.6 happens somewhere in here. And this unshaded, remember, this is the fail to reject region. It's not our critical regions. Those are called critical regions. These are non-critical regions, so that's failed to reject. We figured out our t-score was 0.57, which isn't enough. We needed it to be 2.4 or higher to be significant. So there's not enough evidence to support the claim the average size of the farms are different. So what we're going to do is fail to reject. And so we would write down at 5% significance level, we fail to reject. And conclude the average size of the farms are the same. Okay. All right. Excellent. We'll do 9.4 next.